Good morning, dear students. Welcome back. Today this is my fourth lecture on chemical kinetics. So first we recap some previous thing you have already learned in this lesson. The most important terms you have already learned: order of reaction. So first we recap order of reaction. You know very well the sum of power of all concentration terms in rate expression is called what? Order of reaction. In other words, you can say with the variation of concentration, how the rate of reaction vary. It can be explained on the basis of concept said to be what? Order of reaction. Suppose any chemical equation is given like if rate expression is like this, that is dx by dt is equal to k, then the sum of a plus b is called what? Order of reaction. This rate expression is an experimental fact. So when rate expression is given, then we can predict order of reaction. So order of reaction is not a theoretical concept. It doesn't give the idea of the reaction mechanism. Different types of order of reaction become well known. We have already learned zero order reaction. What is zero order reaction? If rate of reaction is equal to a specific rate constant, or you can say when rate of reaction does not depend upon the concentration of the reactant, then such reactions are said to be what? Zero order reaction. So for zero order, we can write what? dx by dt is equal to k concentration per power 0, or dx by dt is equal to k. What is dx by dt? Rate of reaction. K is equal to a specific rate constant. So when rate of reaction is equal to a specific rate constant, there is such type of reaction called zero order reaction. In zero order reaction, rate does not depend upon the initial concentration, or you can say concentration of the reactant. Today, first we learn first order reaction and expression for first order reaction. So my heading is first order reaction and its expression. Let us consider following general chemical equation: A converted into product if dx by dt k concentration per power 1, therefore order of reaction is equal to what? 1. So such pattern of reaction is said to be a first order reaction. In other words, we can say that when rate of reaction is directly proportional to concentration of the reactant, then our reaction becomes first order in nature. This expression is an experimental fact. Let A converted into product if initial concentration small a, product become what? 0. After time t, the concentration left become a minus x and the concentration of product x. So for first order reaction, we can write what? Dx by dt is equal to k a minus x by power 1. So this is an expression for first order reaction. It is found experimentally. So we can write what? Dx by dt is equal to k a minus x, or dx by a minus x is equal to k dt. Integrating both the sides, that is dx a minus x is equal to k dt. K is constant. This is said to be a indefinite integration. So the integration of dx by a minus x is equal to what? ln a minus x minus is equal to kt plus c, where c is called constant. If t is equal to 0, then x is equal to 0. Therefore, c is equal to what? Minus ln a. Because t is equal to 0, x 0, then c is equal to minus log base EA. Suppose this is equation first. Putting the value of c in equation first, we get what? Minus ln a minus x is equal to kt minus ln a. Again we can write what? ln a minus ln a minus x is equal to what? K. Or you can say ln a by a minus x is equal to kt. According to the concept of mathematics, log a minus log b is equal to what? Log a by b. This is base e. If base e converted into base 10, then multiplied by what? 2.303. So again we can write 2.303 log base 10 a by a minus x is equal to what? Kt. Or you can say t is equal to 2.303 log base 10 a by a minus x divided by what? 1 by k. That is t is equal to 2.303 by k log base 10 a by a minus x. This is our equation second. What is a? Where is equal to initial concentration. A minus X is equal to concentration after time t. K is equal to rate constant and t is equal to time. From equation second, again we can write what? In short form, K is equal to 2.303 by T log base 10. Here we can write C naught by Ct. C naught is equal to initial concentration. Ct is equal to concentration after time t. So this is another form of first order reaction. So equation second and equation third, both are similar equations. From equation third, again we can rewrite. From equation third, again we can write what? In mathematical form, Ct is equal to C naught e to the power minus kt. This is equation 4. Equation 4 is known as Valmy formula. Note T is equal to 2.303, T2 minus T1 is equal to A minus X1, A minus X2. This formula is known as interval formula. Where amount of substance consumed X1 and X2 at time T1 and T2. So when variation of time and variation of concentration is given, then this expression is applicable for first order reaction kinetics. Consider some examples which follows first order kinetics. That is, examples of first order reaction. First one, N2O5 after heating to produce NO2 plus O2. Second one, ammonium nitride after heating to produce N2 plus S2. Third one, all radioactive decay. Such are the example of what? First order. Means in such reactions our rate directly proportional to concentration of the reactant. Our next term is graphical representation. Graphical presentation of first order reaction. Suppose this is x-axis, this is y-axis, and if we draw the graph between rate and concentration, then a straight line become obtained passing through origin. Second one, if we draw the graph between x and y axis, here we consider log base 10 a minus x. In x axis, if we consider a, then this pattern of a straight line obtained, and slope is equal to what? Minus k by 2.303. If we draw the graph between concentration, initial concentration, and T half. What is T half? The time during which the given concentration of the reactant become half from its initial concentration is called what? Half-life. Half-life period for first order reaction does not depend upon the initial concentration. So this pattern of graph become obtained, that is a straight line parallel to x-axis. What is half-life period? Half-life period T. For T half, we can write what? X is equal to A by 2 and T is equal to T half. Putting such value, our initial expression for first order reaction. From first order reaction, we know that T is equal to 2.303 by K log base 10 A by A minus X. For half-life, T is equal to T half and X is equal to A by 2. Putting such value in above expression, we get what? Putting above values in above expression, we get T half 2.303 by K log base 10 A minus A by 2, A cancel, log base. T half is equal to 2.303 K log base 10, 2 is equal to 0.3010. After multiplication, it gives value 0.693 by K. From this expression, it is clear the half-life period for first order reaction does not depend upon the initial concentration. So, for first order reaction, half-life does not depends upon the initial concentration. notes. For first order, T 75% always equal to 2 into T half. T 87.5% always equal to 3 into T half. T 93.75% always equal to 4 into T half. T 96.87% always equal to 5 into T half. And T 99.9% approximately equal to 10 times of T half. For first order reaction, this concept is applicable. For nth order reaction, this is the general expression. Kt is equal to 1 by n minus 1. Here you can write a minus x n minus 1 minus a to power n minus 1, where n not equal to 1. So this is the general expression for nth order reaction. You always remember T half is inversely proportional to a to power n minus 1. For any order reaction. So if for first order n is equal to 1 minus 1 0, anything power 0 is equal to 1 is equal to what? 1. T half is independent for the initial concentration for what? First order reaction. In case of zero order, n is equal to 0. So T half is directly proportional to initial concentration for zero order reaction. Bacterial multiplication, virus growth, or you can say population growth always increases after time t. Such concept is based upon first order kinetics. So we can write what? First order growth reaction, that is bacterial multiplication or virus growth. You can also write population growth. Always follows first order kinetics, and expression become for k minus 2.303 by t log base 10 a by a plus x. Or you can write k is equal to 2.303 by t log base 10 a plus x by a. A is the initial, a plus x after time t. So population, or you can say bacterial multiplication or virus always increases after time t. Next one, it is very important concept, t half first by t half second is equal to a2 by a1 power n minus 1. This is the general expression. On the basis of this expression, we can find out order of reaction, where A1 and A2 are what? Different concentration. When different concentration and different half-life periods are given, then we can predict what? N, where N is equal to order of reaction. In next class, we have to understand some numerical problem based upon zero order and first order reaction. Thank you.